Hello friends, very good morning. Myself, Professor M.H. Annaya, and in today's video, we are going to learn a problem on the impact studies. Friends, an impact load causes an impact stress, which is many times more than the stress caused due to the static load. So friends, let us see what is the question we have in store for today's video. A round steel rod of diameter of length 1.5 is impacted by a 2 kilonewton load falling through a height, and the load is acting axially. So friend, you have a vertical rod and a weight is dropped onto that. So on account of the load, this specimen or the member undergoes compression, that's called a deformation, and you will have to find out by limiting this maximum stress in the member what should be the cross section of the member or the diameter of the member and what is the impact factor. So friends, let us write down the sketch according to the problem given. So friends, we have a round rod which is vertical and it has got a diameter d. The diameter of the rod is d and that is not known to us. So this is d, I will put somewhere here, which is to be found out. And here the member has got a length of 1.5 meter, means 1500 millimeter. And friends, it is being impacted by a load which falls down from a height of h is equal to 50 millimeter. It is dropped onto this member axially, and this is the weight which measures 2 kilonewton, the load of 2 kilonewton, and is asking us to find out what is d and what is the impact factor. Friends, if you are good in referring to the machine design data handbook, and if you are able to select which equation is there on which chapter, and by thorough practice of this, you will be able to know what equation is to be selected. So friends, under this chapter, impact strength, you can just refer to the chapter in the machine design data handbook. And for an axial load like this, for an axial load on a member, the maximum stress is given by the formula sigma dash is equal to sigma into 1 plus square root of 1 plus 2h by y. This is the formula available in the machine design data handbook. I will say here MBH. Friends, on the same line, if it is the case of a bending load, it will be sigma b dash, this is sigma b, this remains the same. And friends, let us see what these terms are. There are totally 1, 2, 3, 4 terms are there. And let us see what are the terms given to us, what are the values given, and what is to be found out. Friends, here, sigma dash is the maximum stress. In the case of axial load, I will say maximum load. It is stress, maximum stress. In the case of axial loading, it is going to be the compressive stress and its value is given to be 150 Newton per mm square. It is given in the question, 150 Newton per mm square. Friends, next comes this term sigma. Sigma is the stress due to static load or static stress. Stress due to static load. That is, instead of dropping the load from a height, if it is kept on this, what is the stress induced? That, friends, is nothing but the load divided by area. Whether it is a tensile load or a compressive load, It is load divided by area of cross section. The load is 2 kilonewton and the area is pi d square by 4, where d is the diameter of rod. D is dia of rod, which is not known to us. Dia of rod. So this, friends, if you simplify, it will be 2 into 10 to the power of 3 Newton. I will take 4 to the numerator divided by pi d square. Friends, if you simplify this works out to 2546.48 divided by that d square. So this d is an unknown quantity. Next comes, friends, the term h. H is height of fall. Height of fall, or the height from which the load is dropped onto the specimen. This height is the height of fall. And that is given to be equal to 50 mm from a height of 50 mm. So I'll put it as 50. So we got this term, known term. This is known. This we have got in terms of d. Then finally we want the value of y, friends. Friends, y is the deflection or deformation of the member. In this case, it is compression of the member. So y is deflection or deformation slash deformation. Means here it is compression because the load is compressive. Friends, for axial load, this is given by WL by AE. PL by AE and WL by AE. What are these terms here? W is the load that is given to be 2 kilonewton, that is 2 into 10 to the power of 3 Newton. L is length of the member that is given to be 1.5 meter, that is 1500 mm. A is area of cross section, that is pi d square by 4. We will written as it is because diameter is not known to us, and E is the Young's modulus of the material of the rod, that is given as 200 GPa. 200 GPa, and if you convert to MPa into 10 to the power of 3 Newton per mm square. Friends, we know all these values, but let's substitute in the formula and see what do we get. So on substitution in the formula, we write down the sigma dash is given to be 150. That is equal to sigma is PLV, just now you wrote. It is 2546.48. 2546.48 divided by this d square, which is unknown, and inside the bracket it is 1 plus square root of 1 plus 2 times 50, 2h, h is 50 mm, divided by the value of y, 190.98, 190.98 divided by d square. Friends, we have to solve this equation, and by solving this equation, because only d is unknown to us, and we get the value of d 39.28. 39.28 mm is the minimum shaft diameter required to sustain this load of 2 kilonewton. And this is the answer for the first part of the question. And friends, in the second part he says, what is the impact factor? Friends, impact factor is defined for as, that is already written here, second part, impact factor is the ratio of the maximum stress in the member to the maximum stress to the static stress or stress due to static load. due to static load. Friends, in this case, it is an axial load. So impact factor is maximum stress. Maximum stress is sigma dash, and stress due to, that is our sigma dash by sigma. Friends, see, we know the value of sigma dash is 150, and we have this sigma in terms of the diameter, that is 2546.48, 46.48 by d square. We have got the value of d already as 39.28, 39.28 square, and this is in the numerator 2546.48. Friends, if you just simplify this value, and here you get the value of sigma, and finally if you substitute this quantity here, you are going to get the impact factor as 90.88, 90.88. It's a number, so I will say impact factor IF is equal to 90.88. Friends, this impact factor depends on parameters like the weight that is being dropped, then the height of drop, and the material properties such as Young's modulus, etc. Friends, I hope the presentation was useful to you, and please go through the video completely. And if you are happy with the video or the presentation in the video, do share the information with all your friends. Have a wonderful day. Thank you very much.